Hello, today we will solve problems based on the concept of electric power, for which purpose I have done this circuit. This is a resistance which is 3 ohm, and this voltage source is a DC voltage source of 6 volt connected across this resistance. Plus this is minus. So due to this voltage source, some current will flow through this resistance, and let this current is I. And what is the voltage across this resistance? The voltage across this resistance is V, that is the same as this voltage. Last time we discussed about the electric power, and we know that the power P that is consumed by this resistance or any element, that is equal to V multiplied with I. P is equal to VI. Okay. So now V is equal to how much? V is equal to 6 volts. 6 volts. And what is I? I is not given here. So we can compute I. How we can compute that is simple, Ohm's law. I is equal to voltage across this resistance divided by resistance. Voltage across this resistance is 6 volt. So I is equal to 6 volt. This 6 volts divided by resistance. Resistance is 3 ohm. This is 3. This is volts divided by ohm. So we get 2 ampere. So the current flowing through this resistance is 2 ampere. Now we can calculate P. P is equal to VI. V is 6 volt, here 6 volts, and multiplied with I is 2 ampere. So I get much, that is 12 watts. So the power consumed by this resistance is 12 watt. Now other formula, that P is equal to V square divided by R. We can also apply this formula. Let us solve this circuit by using this formula. V is equal to V square divided by R. Now V is the voltage across the resistance, that is 6. So it is 6 square divided by R. R is how much? This is 3 ohm. So you get 36 divided by 3, that is equal to 12 watts. Now whether you compute using this formula or this formula, you get the same result. There is also one formula, that is P is equal to I square R. Let us calculate using this formula. P is equal to I square R. I is how much? I is the current flowing through this resistance, that we have already calculated. I square, I is 2 square into R. R is how much? R is 3 ohm. Here you can write R is equal to 3 ohm. So this is 3. So I get P is equal to 4 into 3, that is equal to 12 volts. So we found that whether you use this formula or this formula or this formula, you always get the same value of the power, okay, that is consumed by the resistance. You can see that in this case we did not calculate the current that is flowing through the resistance. We directly calculated using the voltage across the resistance. But here we calculated the current that is flowing through the resistance using Ohm's law, and here also we have to calculate that current. But in this case the calculation of the current is not required. You can directly apply the formula. So while solving the problem, you have to see which is the easiest way to calculate. So one thing that we should remember, that if an element, this is one element, and if this element consumes power, and that means this side is at higher potential with respect to this side, and the current flowing through this is in this direction, then the power will be consumed by this element. And if the element is like this is positive terminal and this is negative terminal, and the current direction is like this, opposite to this direction. Here in this case the power will be supplied by the element. This element will supply the power, and in this case when the current direction is into the positive terminal, then the power is consumed by the element. So you should remember that when the current is entering into the positive terminal of the element, then the element is consuming power, and when the current is leaving the positive terminal, that element is supplying power. So here you can see that the current is flowing away from the positive terminal, just like this case. So here the this element is supplying power, and how much power it is supplying, that is equal to P. P power is supplied by this battery, that is equal to V into I. V is the voltage across this element, that is 6 volts, into current flowing through this is how much, that is we have calculated 2 ampere. So we get 12 watts. So 12 watts is supplied by this battery, and that power is consumed by this resistance that we have calculated by 3 methods. Also for this resistance, this side is plus and this side is minus. It is at higher potential with respect to this one, and the current is entering to the positive terminal. So this case is equivalent to this one. So here the power is consumed by this element because the current is entering at the positive terminal. That's all for now, and we will discuss more next time.